Hello, in this video we're going to do an example of decomposition when a is equal to 1. Decomposition is a technique used to factor quadratics, and it will always work. We do want to eventually move towards being able to do these by inspection, but decomposition is a really good algorithmic approach that you can apply every time without fail. So let's dive right in. So if we take a look at this first one, remember, before we apply trinomial factoring techniques, we always look for common factors, because in doing so, it makes the problem easier. So I'm going to look at each of the terms here and see if there's any common factor. And in this case, there isn't. So that's great. So then what I do is I take a look at this, and I'm going to write down my a term, so a is equal to 1, my b term, b is equal to 10, and my c term, c is equal to 16. So what we want to find is we want to find our product. And our product is always defined as a times c. So in this case, it will be 1 times 16, which is 16. Then we want our sum. Our sum is always our b term, so it's 10. So I ask myself, what are two numbers whose product, which is times, is 16 and sum is 10. Now, this is somewhere where you have to kind of, you can make a table, you can test values, lots of different ways to do this. Some people have neat little diagrams they'll do. I like just to write down test cases. I get my calculator out and jump through some. One way to help with this process is to take a look at the signs of your product and your sum, down here. If my product is positive and my sum is positive, that means that both my numbers have to be positive. So what I'm going to do is I'm just going to start thinking of numbers that can multiply to give me 16. So first one is 4 times 4, and that's 16, right? But the sum of 4 plus 4 is 8, so that's no good. What about 8 times 2, and that's 16. 8 plus 2 is equal to 10, so there it is. So our two numbers are 8 and 2. So this is why it's called decomposition, because what we do is we take that middle term there and we decompose it into those two numbers. And when we do that, it doesn't actually change the expression. X squared plus 10x plus 16 is exactly the same as x squared plus 8x plus 2x plus 16. It just looks different. But that actually lends itself to a nice little algebraic trick. And what that is if I take the first two terms and I take the second two terms and I look for factors there. So I'm going to take the first two terms and factor out what's common. And in this case, x is common. So I get x. So I'm going to be left with x plus 8. Now I do the same thing with the second two terms. So 2. And we get x plus 8. And this is why I love math so much, because it always tells us if we're right. If you've done this right, those two binomials will match. And then what I can do is I can factor out those entire binomials. So I'll end up with x plus 8 times x plus 2. And I have now factored this trinomial. And there you go. Again, it's really nice because you can check your work if there's time and expand this, and you should get the same thing. But notice here how we're looking for two numbers that multiply to give me 16 and add to give me 10. It turns out that that's the same values here. We really want to be able to do these ones by inspection. So that's where we're kind of heading towards eventually. Let's look up at the next one. Now the next one always causes pause because people will say, oh, look at all these numbers, it's a little stressful. But again, what we want to do is always look for common factors first. So I'm going to look here and I can see that I can factor out of this actually. I can factor out, what color am I right now? Let's do gray. I can factor out 6 from each of these terms and an x. So I can actually factor out 6x. And that's going to leave me with x squared minus 3x minus 10. And suddenly this becomes that much more accessible. So here our product is going to be negative 10. Don't forget that negative. And our sum is going to be minus 3. Now again, I have to find two numbers that multiply to give me negative 10, but add to give me 3. But what I can do is I can use the signs to help give me a clue as far as what to do. So if my two numbers multiplied together have to give me a negative, and my sum has to be a negative, that means one number is negative and one number is positive, right? Because a positive times a negative will give me a negative. And I also know that if I think of the absolute value or just the magnitude of each of those numbers, the negative number will be bigger because that means when I add them together, I'll end up with a negative value. So let's just take some values. Well, I know two numbers that multiply to give me 10 are 5 and 2. So the question is, which one do I make negative? Since the sum is negative, I'll make 5 negative. So they, of course, multiply to give me negative 10. And look at that, negative 5 plus 2 is negative 3. So therefore, I can then now decompose this, x squared minus 5x plus 2x minus 10. Students often ask now, well, does it matter the order I write these two middle terms in? And it doesn't. It just works out that you'll actually end up factoring out the other binomial if you switch them. So now I'm going to say 6x, bracket, I'm going to factor out x, so I get x minus 5 plus 2, and I'm going to get x minus 5, so I feel good about my work now. In fact, I'm going to give myself a little check, 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 and now I factor out the binomial. So I have 6x, x minus 5 times x plus 2, and actually these brackets here are redundant, meaning we don't need them. So we're just going to say x minus 5, x plus 2. And we're done. So just a really important point about this question is if you didn't see that common factor, you wouldn't be able to do this one. And if you only saw the common factor in terms of the x part, the x factor, but not the constant, you could still do it, but the numbers are going to be a lot much harder to work through. I hope this helped.